episode of Physics with Noshir Alam, and now we will discuss some non-ohmic conductors. In this video, we'll be covering the graphs of these non-ohmic conductors, and we'll also do some calculations if we have some time. So the first non-ohmic conductor that I want to discuss with you is a diode. Now, a diode has this electrical symbol. This is the P junction, this is the N junction. The thing that you need to know about diodes is that diodes have two states that they work in. The first state is the forward bias state. Now, when a diode is in a forward bias state, remember that the resistance of the diode is minimum. The diode allows current to go through it. And then to achieve this forward bias state, the P side must be connected to the positive terminal of the battery, and the N side must be connected to the negative terminal of the battery. In easier words, you have this diode, it must be connected in a circuit like this, and if it's connected like this, you will say it is forward biased. It will allow all of the current to go through. Now, the second state is the reverse bias state. When you talk of the reverse bias state, the first thing is that the resistance of the diode will be infinite when it's in reverse bias. If the resistance is infinite, it means it will not allow current to go through. And the third thing is, how do you achieve this? You connect P to the negative terminal of the battery, and you connect N to the positive terminal of the battery. So basically, in your diagram, if we reverse these connections, and now N is connected to the positive and P is connected to the negative, in such a case, the current will not flow through the diode. Basically, the diode will act, diode to hai yahan pe, but the diode will basically act like an open circuit. So there is no current in your circuit. Now, for a diode, the graph of current versus voltage looks like this, where this is the forward bias region and this is the reverse bias region. Reverse bias means you can notice that the current is 0, and here you can see that the current is increasing as the voltage is increasing. So that is the current versus voltage graph for a diode. The second component that we will discuss with you is an LDR, which is a light dependent resistor. The symbol for an LDR is like this. Now, for an LDR, you must understand that depends on light. So if the light intensity on it increases, the resistance of the LDR falls. And if the light intensity on the LDR decreases, then the resistance of the LDR increases. Iski wajah kya hai? What's the reason behind this scenario? You will discuss in A2 in detail. So when light intensity increases, that means it's daylight or bright conditions. And if the light intensity decreases, that means it's night condition. And that's how the resistance changes. Now, bearing this in mind, if you sketch a graph of resistance versus light intensity, you will get a downward sloping curve like this, which is basically telling you that as light intensity increases, the resistance decreases. Keeping this graph in mind, if you were to sketch an IV curve for this graph, for this scenario, for this LDR, the IV curve, please have a look, that the resistance is decreasing as light intensity is increasing. So if the resistance is falling, the current is bound to increase, and therefore the curve would look like this. So for an LDR, this is the IV curve. If you reverse the axes, which means V is over here and I is over here, remember that the current graph will look like this. One thing which you must understand, that this part will always be inclined. Please never make it flat. We must show an inclination, never flatten it out. Please एक बात याद रखो कि देखो resistance is falling in this graph, right? And when the resistance is falling, then the current has to increase. तो आपके जो दोनों graphs हैं, ये वाला भी और ये वाला भी, इन दोनों को एक ही चीज़ दिखानी चाहिए, that is that the current is increasing. Now the only thing that you have to do is you have to locate the current axis, and once you've located it, all you have to do is कि अपने graph को current axis की तरफ turn करना है, graph को current axis की तरफ turn करना है, and you will never go wrong with the graph because current increase हो रहा है तो graph को current axis की तरफ turn करना है. अगर current decrease होता तो current हम graph को दूसरी तरफ turn कर देते, voltage की तरफ turn कर देते. That's how this goes. All right, and then now the third graph. The third one is a thermistor. Now when you're discussing a thermistor, the symbol for a thermistor is like this. Again, when you heat up the thermistor, the resistance will decrease. If you put the thermistor in cold conditions, the resistance will increase. Again, you sketch an IV curve for this scenario, and the IV curve would again go towards the current axis as you heat it up, and the VI curve again would go towards the current axis because as you heat up the resistor, temperature बढ़ाते जाओ. तो आप ये याद रखें कि ये दोनों ग्राफ जो बने हुए हैं, this is bearing in mind that the temperature is increasing. सही है? So that's what we generally do when we are considering thermistor के basic graphs, if they ask you to make characteristic graphs. And then filament lamp. For a filament lamp, please try to understand that as the current through the lamp increases, the resistance of that wire increases, and then eventually it causes the current to become constant. So current increase होना बंद रहता है. So current pass करता है एक coil में से, एक wire में से, like this is the coil and the current goes in and the current comes out. So this coil starts to heat up, the temperature starts increasing. Now because the temperature starts increasing, the resistance increases. Resistance increases, it causes the current to stop increasing basically. मैं ये नहीं कहूँ current कम होता है, I would say that the current stops increasing. So if you bear this story in mind and you sketch an IV curve, हमने कहा है कि current eventually has to stop increasing. Now just some time ago when I was discussing the other curves, I said कि current increase होता है, तो ask yourself, current increase होता है तो ग्राफ किधर टर्न करेगा? करंट की तरफ. अब करंट पहले ज़्यादा था, फिर रेजिस्टेंस के बढ़ने की वजह से करंट ने उतना इंक्रीज अब नहीं होना, तो ग्राफ इज़ नॉट गोइंग टू टर्न टुवर्ड्स द करंट एक्सिस. बिकॉज अगर देखो यहाँ पे टर्न करता है टुवर्ड्स द करंट एक्सिस, तो वाई एक्सिस पे करंट की वैल्यू से करंट बढ़ता ही चला जाएगा. करंट वोंट स्टॉप. यू हैव टू इवेंचुअली स्टॉप इट फ्रॉम इंक्रीजिंग. सो द ग्राफ वुड लुक लाइक दिस. Remember that you must show its inclination. And if you reverse the axes, which means voltage is here and current is here, remember कि current को रोकना है बढ़ने से eventually. So current बढ़ता गया but slow down कर रहा है, अब उतना तेज से नहीं बढ़ रहा. So you can see that शुरू में it increases very quickly but then it slows down. These are your graphs. Now in any of these graphs, if they ever ask you to find out what is the resistance at this point or that point, या पीछे वाले ग्राफ के अंदर चले जाओ, किसी भी ग्राफ के ऊपर, which is a curve, which is not a straight line, the resistance will be found by simply considering the coordinates of that point. So whatever the coordinates of these points are, for example, this point coordinate is 2, 3. Just giving an example. So that means 2 is your voltage, 3 is your current. Just use R is equals to V over I and get the answer. इसी तरह इस curve के ऊपर, if let's say the coordinates are 4, I don't know, 3, just as an example. That means 4 is your current and 3 is your voltage. Just look at the axes. Resistance निकालनी, resistance is V over I. For any curve, you remember that you just take the instantaneous points and you will get the resistance at that point. No need to make tangents. However, if they ask you to discuss the voltage versus current graph for a fixed resistor, okay, so ये भी तो question हो सकता है कि discuss करें for a fixed resistor. If that is the case, then you will have I over here and V over here, or the second option is you will have V on this axis and I on this axis, and in both cases it's a straight line. Oops, should be a straight line. Let me try. Straight line. Straight line. Now the gradient of this line would give you 1 over resistance, so the resistance would be 1 over gradient, and in this case the gradient itself would be V over I, so the gradient would represent resistance. Remember that this fixed resistor is an ohmic conductor, और सिर्फ जो ohmic conductors होते हैं उनके लिए you use the gradient method, otherwise you just take the instantaneous points and you get your answer. Alright, now in summary of this lecture, I'm going to discuss 2 examples with you. You can see 2 circuits, one is this one is this one. One key difference, इसमें यहाँ पर बैटरी के डायरेक्टली साथ एक रेजिस्टर लगा हुआ है, यहाँ पर बैटरी की डायरेक्टली कोई रेजिस्टर नहीं है. You've just got 2 branches. Alright, so this is one branch, this is another branch. Here you've got 1, 2, and this is, I won't call it the third branch, but there's this resistor in the middle of these 2. Now, excuse me. Now, the way to solve any of these questions, मैंने दोनों parallel चलाने, because इसी में आपकी सारी confusion है. बहुत से लोग ये गलती करते हैं, जो इसको सही solve करते हैं वो इसको गलत solve करते हैं. And I'll tell you what the mistake is. Let's first solve this one, the easier one. So the first thing that you need to understand, please understand that there are multiple ways to solve this question. But there's no particular way. This is one way that I'm discussing with you. What I do is, I think I told you the strategy. What I do is I drag the terminal. So this is the positive terminal, right? ये positive terminal यहाँ से drag करना शुरू करता हूँ यहाँ तक आ गया. When I bring it to this point, there was no resistance over here. So that means that if this was my positive terminal, then this positive terminal is here. And likewise, if I drag the negative terminal up to this point, there is no resistance as such. So that means that I can write the minus over here. So that means this is plus 10 and this is 0. Negative का मतलब होता है 0 volts. So you can clearly see that the voltage at this point is plus 10 and the voltage at this point is 0. And if you want to find the current through this particular branch, तो इसके across देखें क्या voltage है यहाँ पे. You will see that the voltage across the 5 ohm resistor is 10 and 0. So that means 10 volts is the voltage difference and the resistance itself is 5. So the current I1, let's say I1, the current that the name was already given, the current is I2. I2, the current that you get will be 10 minus 0. Why 10 minus 0? Because 5 के एक side पे 10 था, दूसरी side पे 0 था, so 10 minus 0. That's the potential difference divided by the resistance itself, which is 5. So the current is 2 ampere. I2 is 2 ampere. Now, let's have a look. 2 or 3 are connected in series. Okay, so because the same current जो I3 है वो पहले 2 में से जाता है, फिर 3 में से जाता है और यहाँ पे आता है. So if the same current goes through two resistors, पक्की बात है they are in series. Now 2 के इस साइड पे वोल्टेज 10 है, ठीक है, और 3 के इस साइड पे वोल्टेज 0 है, और आपको ये तो पता चल गया 2 and 3 are in series, so their total resistance is 5. अब इस 5 के एक साइड पे वोल्टेज 10 है और 5 के दूसरे साइड पे वोल्टेज 0 है. So again, if I write down my equation, which is I3 निकालने के लिए, I3 is the current that is going through these two. The voltage on one side is 10, so I write 10. The voltage on the other side is 0, so I'll write 0. और फिर आप देखें कि इस ब्रांच में कितनी रेजिस्टेंस थी. सिर्फ जिस ब्रांच को आई एम डूइंग इन अ डिफरेंट पेन, इस ब्रांच के अंदर रेजिस्टेंस was 3 plus 2, which is 5. So that's also 2 amperes. So you get 2 amperes over here. So 2 amperes going in I3 as I3. 2 amperes I2. And the question is, what is I1? Try to understand that I1 was the total current coming from the battery. So I1 जो था वो split हुआ था. कुछ 2 ampere इधर गया था, 2 ampere इधर गया था. So what is the total that is coming out? I1 is going to be 2 plus 2, which is 4 amperes. Now that is the strategy, one of the ways to solve. Somebody else can have another way. Let's look at how this question is different from this one. And why can you not use this strategy on this one? Let's start with the terminals again. And why will the terminal strategy fail here? So this is plus 10 volts. हमेशा पॉजिटिव वोल्टेज होता है, जो बैटरी का EMF होता है उसका पॉजिटिव टर्मिनल का वही वोल्टेज होता है, और जो बैटरी का नेगेटिव टर्मिनल होता है दैट इज ऑलवेज एट 0. सो 10 volt minus 0 volt will give you 10 volts, right? So I'll repeat, जब भी EMF लिखा हुआ सेल का, so जो सेल का पॉजिटिव टर्मिनल है उस पर वो वाला वोल्टेज लिख के write a plus 10, and the negative terminal of that cell just write 0, and that's 10 minus 0 would give you 10, the EMF. If you consider the same dragging strategy, the problem would now be that when you dragging it, तो ये पॉजिटिव टर्मिनल यहाँ पे आके रुक जाएगा, इससे आगे नहीं जाएगा. क्यों नहीं आगे जाएगा? ये रेजिस्टर बीच में आ गया. So that strategy fails completely. That means that you cannot simply say, oh, this 10 is over here and this 0 is over here, so 10 divided by 5 is 2. गलत हो गया. Failed. This 10 cannot even cross this 7.5, so you cannot use that strategy. In such a case, what you do is you go to the extreme opposite end and start working your way backwards to this side. Firstly, ask yourself, ये जो I3 current है, ये 2 में से गुजरा है और ये इस 3 में से गुजरा है. That means that these two resistors were in series, so that means that 2 plus 3 will give you 5 ohms, right? So what I can do is I can redraw my circuit and I can say that this 2 plus 3 gives me 5 ohms. All right. Now 5 ohms ये आ गए, और इन 5 ohm में से जो current गुजर रहा है, in a different pen, that is I3. Now you have the middle branch, that is also 5 ohms, और उसमें से जो current गुजर रहा है, that is I2. And then you have the third branch, this one, where you have 7.5 ohms, and you have your cell connected here, and the current that is coming is I1. All right, so now again let's go back. Problem, you cannot drag the terminal beyond 7.5, तो आपको इधर वोल्टेज नहीं मिलेगा, तो इस वाले क्वेश्चन में जो स्ट्रैटेजी लगाई है वो यहाँ नहीं चलेगी. इसको सॉल्व करो फिर से. देन यू नो कि आप ये देखें, ये वाला 5 जो येलो में है और ये वाला 5 जो रेड में है, इनके 2 टर्मिनल्स कॉमन है. One terminal is this one and the other terminal is this one. So when two resistors, these two, have 2 terminals in common, they're parallel. So that means this 5 and this 5, they are parallel. And when 2 resistors are in parallel, you can use R1 into R2 divided by R1 plus R2. That's the strategy. That's the formula that I told you. So that means कि इनकी जो combined resistance बनेगी वो क्या बनेगी? वो बनेगी 5 divided by 2, which is 2.5. 5 into 5, 25, divided by 5 plus 5 is 10, so 2.5 आ गया. ठीक है? So 25 over 10, 2.5, use the shortcut 2 resistors in parallel. So I'm going to rub these two off, and I'm going to make them as 1 now, and that one resistance will have a value of 2.5 ohms. So I'm rubbing it, and let's put just one resistor over here which has a value of 2.5 ohms. So now notice 10 volt battery, current goes here 7.5, कोई split नहीं होना, नीचे आना है और यहाँ से वापस. And now there is just one current left, which is I1. Please remember कि आप I2 और I3 क्यों नहीं लिख रहे. उसकी वजह ये 2.5 ओम जब आपने कंबाइन किया, 2.5 ओम आपने जब बनाया, तो आपने 2.5 ओम बनाने के लिए इस ब्रांच को और इस ब्रांच को, इस ब्रांच में ये दोनों आते हैं, आपने इन दोनों ब्रांचेस को कंबाइन किया. जो आपकी ये वाली ब्रांच थी 2 और 3 वाली, उसमें करंट था I3. जो ये वाली ब्रांच थी, इसमें करंट था I2. रिमेंबर व्हेन यू कंबाइन द ब्रांचेस टू गेट वन रेजिस्टेंस, तो करंट्स भी कंबाइन हो जाते हैं. मीनिंग I3 तो जा रहा था, I2 तो जा रहा था, तो 2.5 की जब बात करोगे तो इसमें I2 और I3 दोनों हैं. एंड इफ यू लुक एट दिस सर्किट, I1 came in and split into I2 and I3. That means that you could have written that I1 was equals to I2 plus I3, isn't it? So I2 और I3 जब combine होंगे तो क्या बनेंगे? I1. Which is why, and it makes perfect sense, कि आपने जब 2.5 ओम का रेजिस्टर बनाया है तो इसमें से करंट कितना गुजरना चाहिए? ना I2 ना I3, बल्कि I2 plus I3. And what is I2 plus I3 equal to? I1. And that is exactly what is happening in your simple circuit, कि आपने जब सब दोनों को combine किया, दो branches को, तो जो current पीछे रह गया, that was simply I1. Now I1 is the current that is left in this circuit. And what is 7.5? Now what do you do? 7.5 and 2.5, are they in series or parallel? Ask yourself. The same current is going through them. So 7.5 and 2.5 are in series, definitely. Add them. What is the total resistance? The total resistance now would be 7.5 plus 2.5, that is 10 ohms. And what is the EMF? The EMF is 10 volts. If you remember, I told you EMF is I total into R total. That means 10 volts is equals to I total into 10 ohms. That means that you get 1 ampere. So I1 is 1 ampere. I hope you are with me so far. Now, once you get I1 as 1 ampere, the question would be, what is I2 and I3? So one quick comment, and we're done with this lecture. My comment is कि I total को मैंने I1 क्यों बोला है? ये आपको पूछना चाहिए था अपने आप से. I total को I1 इसलिए बोला है because I total means coming out from the battery, and what is coming out from the battery in the question? I1. So I1 is 1 ampere. Now I1 goes through this 7.5, reaches this point, and then it splits. So I1 का कुछ हिस्सा, मतलब 1 ampere, कुछ हिस्सा इधर आएगा और कुछ हिस्सा इधर आएगा. It's so easy, isn't it? I hope you've gotten the answer now. देखो, दोनों रस्तों में resistance same थी. इधर भी 5 ohm है और इधर भी 5 ohm है. So what does that tell you? I2 and I3, should they be equal, yes or no? Yes, they should be, because I1 जितना आया है वो दोनों में equally split होगा. क्यों equally split होगा? दोनों में resistance same है. तो कितना कितना होगा? आधा आधा. That means 1 ampere divided by 2, which means that 0.5 ampere current is going in the 5 ohm resistor, and 0.5 ampere current is going here. So I2 is equals to I3 is equals to 0.5 amperes. I hope you've understood the basics of this circuitry. Great. Best of luck. Practice hard and wait for the next video.